and welcome back to News Kim Corner. In today's video, I'm gonna introduce a new series, a basic series. As an online tutor, I have noticed there's something important like students need some core basic part. So in this series, I'm going to introduce all those basic part you need to understand before you are taking AP Chemistry. See, it's very important. Do not cut corners while you are dealing with the basic topics. Through this series, you can get a plethora of information. Of course, it's not exclusively for AP Chemistry. If you are doing honors chemistry, definitely this will work for you. And yeah, I don't want my speech to run out. Let's get started. So in this series, we can start with the significant figures. So do you know what are significant figures? Yes, significant figures are the digits in a number that contribute to its accuracy and precision, right? They indicate the number of digits that are reliably known, including the last digit in an uncertain but still significant. You may didn't get the idea. So in simple way, we can tell significant figures are like in a measured number, all digit including estimated digits are significant. So what does it mean? What do you mean by measured number? Measured number means we are using like measuring tool, okay, in order to find the length or something like that. Okay, for example, see in this the length of the scale or length of this substance, what it is, it's in between 4 and 5, right? We are using a ruler and see in between 4 and 5. So you can't write like 4, you may write like 4.5. Okay, so you are okay with the 4, up to 4 there is no doubt. All right, and this one 0.5 is an estimated digit actually. Okay, similarly here what is an unit? Here 4.5 there is no doubt, correct? And the 4.5 after the 4.1 you can write like 4.55 like that. Okay, so here up to 4.5 there is no doubt, and this 5 is estimated digit. Okay, anyway those estimated digit also you can count like a significant figure. Okay, so there is a rule, set of rules are there to count the significant figures. So what are the rules? So basically significant figures implies or it shows the accuracy and precision of a measurement. Okay, so what are the rules? How to count a significant figure? So this, see, you may find like several set of rules are there, but actually nothing. You can just study these two rules in order to find the significant figure. Okay, all the non-zero digits are significant. The first rule says that all the non-zero digits are significant. And the second rule says that zeros are significant in two cases. Okay, what are the cases? Zeros, if the zero is in between two non-zero digit or the ending zeros with the decimal point. Okay, only these two cases the significant figures are countable, like the you can count the significant figure. Okay, so don't want to study any like if you study any like what textbook or something like that, you may see several rules are there, some 10 or 11 rules are maybe there, but nothing, you can just conclude the two rules like this. Okay, all the non-zero digits are significant and zeros are significant in two cases: zeros in between two non-zero digit and ending zeros with the decimal point. Okay, let's see what is this one. For example, if this is the number, these are the numbers, what you can say, the first digit, look at the first digit, 2.34. How many significant figures are there? We found, like we studied, like all the non-zero significant figures are all the non-zeros are significant. So 3 significant figures are there. Okay, and see this thing, how many significant figures are there? Is it 1, 2, 3, 4, 5, 6? No. Okay, because what we told, zeros you can count only when two situation. What are the two situation? If zeros are in between two non-zero digit or ending zeros with the decimal point. Okay, ending zeros with the decimal point. Here this is not ending zeros, this is initial zeros, right? Leading zeros, so not countable. So you can count only 3, 4, 5. Okay, only these 3, 4, 5 you can count. So 3 significant figure again. Okay, then how many significant figures are here? This 0 is countable because it in between two non-zero digits. So 1, 2, 3, 4 significant figures are there. And see, This 0 is also countable because it's in between two non-zero digits. So 1, 2, 3, 4 again. And what about this one? This is ending 0. It's countable only when decimal point is there. So see here decimal point is there. So definitely you can count this 0. So 3 significant figure. And how many significant figure is there for 300? See the ending 0 but see no decimal point. Okay, so that's why you can't count that zeros. There is only one significant figure. And what about this number 1.001? So see, sorry, 1001. The both zeros are countable because it is in between two non-zero digits. So 2. And what about this one? How many significant figures are there? In this kind of scientific notation. Okay, what we called scientific notation. In this kind of scientific notation, we don't want to count that 10 powers. Okay, the exponents you don't want to count. You can just count this number. Okay, so how many significant figure is there in this number? This 0 is countable because in between non-zero digit. So 1, 2, 3, 4. Okay, this is how we need to count the significant figure. This is the two symbol rule. Okay, right. Then there is some special cases are there. Okay, what are the special cases? There are two special cases I can tell. One is when you are dealing with a logarithm like pH. Mostly you are doing with a pH calculation. Okay, while you are telling pH is equal to suppose 6.23 or 32 is the pH. So how many significant figure is there? Normally we will count like 6 is also significant, 1, 2, 3 like that, 3 significant figure like that we told. Okay, but that is wrong. Okay, in while dealing with the pH, after the decimal point, like after the decimal point only we can count. Okay, see the part of the pH to the left of the decimal point has no effect on significant figure. So 6.32 have only two significant figures. Okay, while you are dealing with the pH values, be careful, do not count all the values. Okay, suppose pH is equal to 13.3. How many significant figure? Only one significant figure. Okay, after the decimal point only you need to count. Clear? Right, that's the first special case. And the second special case, as I told you, you are not going to count significant figure while dealing with the exact number. So what do you mean by exact number? As I told you, there are two numbers, measured number and exact number. Measured number means you are using a like scale or something, ruler or something like we have a tool, measuring tool will be there. So by using that measuring tool, maybe measuring jar, whatever it is, by using a measuring tool, you are measuring something. That is what we called measured numbers. Okay, only we are dealing with the measured number. We are using the significant figures. Otherwise, significant figures there is no meaning. Okay, like what is exact number? Okay, suppose someone is asking you how many apple you ate today. So you may tell like one apple or two apple. So that is just counting numbers. Okay, that you can't say it's a like one significant. Suppose you are telling two apple you ate, you can't say one significant figure is there. That is wrong. Okay, because 2 is a counted number, like counted number, it's an exact number. Okay, so that's why you don't want to tell significant figure. There is no meaning on significant figure about in this case of exact numbers. Okay, right. Then what we are going to do is significant figure in calculation. So the important point is when you are represent an answer, when you are doing some calculation, you need to know this significant figure rules. Okay, how to represent an answer. Got it? How to represent an answer. Suppose you are doing addition and subtraction, the rule says that there is no need of counting significant figure. Okay, then what it should be? The presented answer should be the same number of decimal places as the measurement with the fewest number of decimal place, which means see the number. If these three numbers, if you want to add, what happen? You can just add this number and when you are adding you can get this kind of number in your calculator. Okay, then what to do? How do you represent this answer? According to the sign figure rule, what we studied, addition and subtraction, do not want to count the sign figure, just look at the decimal place. See, the um, first digit have 3 decimal place. Okay, and the second number also have 3 decimal place, and the third number have 2 decimal place. So your answer should contain 2 decimal place. That has to be, the answer should represent in that way. Okay, so how do you represent in 2 decimal place this number? 0.16. Since this number is less than 1, you can round, like you can just write like 0.16. You can drop that number, right? So 0.16, this should be the form of answer to be represented. Okay, and see the next one. Here again it's addition and subtraction, so again the same rule, 3 decimal place, 3 decimal place, and 0 decimal place. Okay, here 7 gram, it's just a 7 gram, so 0 decimal place. So again you can represent the answer with a 0 decimal place. So look at the number 14.331 maybe you got, but you have to represent like 14. Okay, again this number is less than 0.5, right? Less than 5, so you can drop that number. Clear? Okay, then see the rule, second rule. When you are dealing with the multiplication and division, what happened? Significant numbers, significant figures plays the role. So lowest, the answer should represent like a least number of figures. Okay, so for example, see the number here, this multiplying number have 3 significant figure. Here how many significant figure is there? And not 3, it's only 2, because you know initial zeros are not countable, leading zeros are not countable. So 2 significant figure. So your answer should contain only 2 significant figure. So how do you represent this answer? 2.5 is wrong. Why? Because see, after the 5 this is 6, so greater than 5, so you can write 2.6. In that way you can round the answer. Okay, so multiplication and division you can write like lowest significant figure, not decimal place, lowest significant figure should be there. Okay, then suppose if mixed operations are there, what to do? If mixed operations are there, do the denominator and numerator first, applying the significant rule for addition and subtraction first, and then do the division and apply the rules for division and multiplication. If you didn't get, see the example. See here, multiple operations are there, so you can do numerator and denominator separately. So 12.5 minus 9.35. What is the rule? Subtraction, so lowest decimal place. So your answer should contain 1 decimal place. And again, see the bottom. Bottom is again addition, so again lowest decimal place, but both of them is 3 decimal place, so your answer should contain 3 decimal place. Okay, and now see the rule. Now it is just division. So division, what is the rule? Lowest significant figure. So here this contain 2 significant figure, and this one contain 1, 2, 3, 4, 5, 6. 6 significant figure. So your answer should contain only 2 significant figure. Okay, so see the number 0.023. 0.023 contain only 2 significant figure. Got the idea? This is the way of operation. Okay, now let's do this question. How many grams of octane must be burned to produce 15,100 joules of heat? Okay, so they were given some data here. Grams, see this kind of dimension analysis question you can expect. Through dimension analysis you can do this problem. So how do you start with? You can always start with the given stuff, right? So this is the given stuff. 15100 joules are there. Okay, so you need to cancel the joule. So joule should be the bottom. And is there any relationship? Yes, they were given 1 mole of octane produce 5450 kilojoule. See, kilojoule. So what is the conversion? Kilojoule, 1 kilojoule, 1000 joules are actually 1 kilojoule. So you can just convert 10 to the power of 3 times joule. Okay, right. Then 1 mole have to cancel out, then that is should be the bottom, and the top will be 114.23 gram. Okay, so see, we need gram, so we can stop the dimension analysis here. Joule will cancel, mole will cancel, so your answer should be in gram. Okay, and also how many significant figure you need? How many significant figures are there in the question? Yes, this number contains 3 significant figure. And do you really want to count this as one significant figure? So your answer should contain one significant figure? No. Okay, that's why I told you exact numbers. You don't need to count the significant figure. So you can represent the answer with a 3 significant figure. Okay, so what's the answer? What I got is 316.494. Okay, I'm just taking 4 and minus 3. So this is the answer I got. But how many significant figure? I need to represent in 3 significant figure. So 316 is sufficient. Okay, so zero point 0.4 is not needed. 316 times 10 to the power of minus 3. Okay, and that's it for today's video. If you found this helpful, give it a thumbs up and share it. Subscribe to Anu's Chem Corner for more videos. I will come back with another basic topic in next video. Bye.